Because Einstein told us that everything that has energy has a gravitational field around it, and either attracts or repels.
But what is that gravitational field?
It's the curvature of space. So a photon that has energy curves space around it.
Wait a minute. You mean that curvature? That curvature.
Little thing curves space a little teeny bit.
Is what?
And you curve space around you. Right now, space is curved around you because you have mass.
What does that mean?
That means that if I send a beam of light,
being disproved.
Well, Einstein so far hasn't, but what he showed. But first of all, actually, let's go back to Galileo. Good old Galileo, one of my heroes.
Looking up at the sun goes around.
Galileo was hysterical. You should read him. He was very funny. He was his book on the two new sciences is hysterical to read.
No,
but anyway, probably one of the reasons the church hated him. But anyway, so Galileo was the first one to show that, you don't need anything to push something, have it keep going. You need to apply a force to stop things. If something's moving, it'll keep moving forever unless you stop it.
It's got its impetus from somewhere.
No, you gave it a kick, but once it's moving.
I didn't. You didn't. What gave it its kick?
Okay, now the weird thing about photons is
it's so. I'm reading a lot of history, and I'm reading like the Battle of Actium, which was the battle that separated Antony and Cleopatra from. I love
reading Roman history myself. Yeah,
right. It's fascinating. It reads like a novel.
It's amazing.
And then she went, and then he did, and they got escaped, and they went. So science is like that as well. It's like. Every discovery is like a new chapter. You're like, no kidding. And then then the photon did what? And then there was the logarithm, and it's like it goes on and on. It's a never-ending novel.
And I'll give you an answer, and you'll hate it. Energy is the source of gravity.
That's called elliptical.
Yeah. But it's
that's what I mean. See,
just like the X and Y axis are not quite the same. The mathematics is a little different.
Larry, but that totally escapes me. You're going to have to.
I'll show you. I'll give you an example. Take my pen.
Yeah.
It's moving very fast, close to the speed of light.
Right.
Well, if it is moving very fast with respect to you, close to the speed of light, you will see my pen, and it looks shorter. It'll, instead of being, say, 6 inches, it'll be 4 inches. Okay. It'll be 4 inches, and you'll measure it going past. You'll say it's only 4 inches long. Okay, so it's shrunk in space. That really happens. When things move close to the speed of light, relative to other objects, their length shrinks.
I thought that was time that shrunk.
No. Time dilates. It goes in the other direction.
Well, dilate shrinks. Dilation is shrinking.
Dilation is expansion. But hold on, forget the word. Let's forget the word.
Your eyes
dilate. When you take bottles, your eyes dilate.
Dilation is getting enlarges. Okay.
Yeah, okay.
But what's the opposite of dilation?
What's the opposite of dilation? Shrinking.
Yeah.
Yes.
Okay.
Anyway. Okay. As is my argument. But anyway, so this pen is now smaller when it's moving very fast with the speed of light. But the really weird thing is that if I have a little clock on either end of my pen, and I set them up so that they're exactly the same time. When this ticks 12 noon, this ticks 12 noon. When it's moving very fast with respect to you, this clock is ahead of that clock. So the pen has shrunk in space, but it's got extended in time. It used to be that this and this had the same, where it's instantaneous. But now, when you look at it, it's smaller. But if you look at this clock and this clock, you'll say, no, this clock is behind this clock. This one's a second faster than this clock. So it will extend in time and contract in space. Just like here, watch this. Watch my pen. See how it got shorter? It got shorter because projected to you, the amount of the pen that you can see perpendicular to the screen right now gets smaller and smaller and smaller until the pen looks very, very short indeed.
But that's a function of sight.
It's a function of
artists worked with that.
Exactly, it's a function of sight. But the reason it's sight, it's a function of 3 dimensions. It's the fact that I can rotate in an extra dimension. If that extra dimension was there, I couldn't rotate it.
But in fact, the pen is the same length. It's just sight. But my instruments are measuring it incorrectly.
No, they're not. No, they're measuring it correctly. They're measuring the X component.
Name is Trank. And federal agents told us the drug has already made its way to New York City. It's mixed in the fentanyl and the heroin supply. It's eating away at people's skin. Mary Murphy joins us now at the preview of our special report at 10 p.m. Mary.
Hi, Corey and Tam Singh. My colleague John Frazzi and I have been in